Hello everyone. In the previous videos we have learnt about the permutations in which we were arranging the objects in a straight line. When we arrange them in straight lines, arrangements in straight line, that is known as linear permutations. Now suppose we want to arrange those objects in a circular way or in circular order we say, then that is known as the circular permutations. Circular permutations. So as we have discussed just now, that any of the objects we are arranging in circular order, that is known as circular permutation or circular permutations. Suppose we have n objects in total and we want to arrange them in the circular order like this. Here we have 1, 2, 3, 4, 5, 6 and so on. We have this as n. Now there is no beginning and no end to all these objects. And that's why what we do, we can arrange or we can start from any of these n places or not, which can be done in n different ways or not. It means we can start in n different ways. But in case we want the linear permutations, the linear permutations of n objects was given by npn, that is factorial n or not. It means when we arrange them in the circular order, the number of circular permutations will be 1 upon n into factorial n. And that's what it is, 1 upon n into factorial n minus 1, which is equal to factorial n minus 1, or we write this as n minus 1 factorial. It means the circular permutations or circular arrangements of n different objects can be done in n minus 1 factorial ways. Now suppose you want to arrange them in such a way that two neighbors are never together in two different orders. Neighbors are never together again. Then what will happen? See, here these two are adjacent to each other, they are the neighbors of each other, but we don't want that they should be in the same order again, or they should be neighbors of each other again, but certainly they will be together in the second order again, and hence the number of such permutations will be will be equal to half of factorial n minus 1. That is just half of the orders. So here we can see that when we arrange n objects in circular order, that is factorial n minus 1. And in case we want that the neighbors are not to be together in the second order, then that will be half into factorial n minus 1. Generally, this particular thing is used when we are making the garlands of flowers, beads or pearls, etc. Let's take some of the examples now on the circular permutations. But before that, if you have not subscribed the channel so far, please subscribe it and watch the video till last. See, now the first example we have, in how many different ways 6 persons can sit around a round table. that is a circular table or round table, it means we have to make the circular arrangements, so we will be applying the circular permutations. Here we have number of persons is equal to 6. Therefore, number of circular permutations we have the formula factorial n minus 1, that is factorial n minus 1 or factorial 6 minus 1, that is factorial 5, and we know the value of factorial 5 is 120. So in 120 different ways 6 persons can sit around a round table. Now the second example we take, how many different garlands can be formed from 9 different flowers? 9 different flowers. Number of flowers we have 9. So the number of garlands which can be made will be what? The formula is half into factorial n minus 1. That is half factorial n minus 1. Half into factorial 9 minus 1. That is half into factorial 8. And we know factorial 8 is 40320. So this is half into 40320, which is equal to 20160. It means 20,160 garlands can be formed from 9 different flowers. The next example we have that there are 7 boys and 4 girls. In how many different ways they can sit around a round table to dine, such that no 2 girls are together. See, here we are finding 7 boys. 7 boys will sit in 7 different positions around the table. See, this is like 1, 2, 3, 4, 5, 6, 7. We are marking the positions of boys with red. And we know that since we are arranging them in the circular order, the circular permutations will be applied. So we can write number of boys is equal to 7. Their circular arrangements will be how many? That is factorial n minus 1 or factorial 7 minus 1, which is equal to factorial 6. And we know the value of factorial 6 is 720. Now we have to arrange the 4 girls between the boys so that no 2 girls are together. How many other places between the boys we are finding here? That is 1, 2, 3, 4, 5, 6, 7. Out of these 7 places, any 4 can be occupied by these 4 girls. Number of girls we have 4, which can be arranged between the boys in 7 places, in 7p4 ways. Why permutations? This is because now they are arranged like linear permutations only between the boys. So the total number of arrangements or total number of permutations will be factorial 6 into 7p4. That is 720 into 7 into 6 into 5 into 4. This is equal to 720 into 4, 5 20, 6 120 into 7, that is 840, which is equal to 604800. It means 7 boys and 4 girls can be arranged in circular order with the restriction that no 2 girls are together in 6,04,800 ways. The next example we are going to discuss is how many different garlands can be formed from 8 different flowers so that 4 special flowers of them are always together. So number of flowers here we have 8 in total, out of which 4 are special flowers. 4 special flowers are to be together. So this is also a restriction here. And we know in case 4 objects out of 8 objects are always together, then we consider these 4 as one particular object or not. We can write here which can be considered as one object. Therefore, total number of objects will be how many? That will be 8 minus 4 plus 1, that is equal to 5. Now these 5 are to be arranged in circular order and we have to make the garland of them. Number of circular permutations of these 5 objects is equal to half into factorial 5 minus, that is half into factorial 4. But these 4 flowers which are always together can also be arranged in factorial 4 ways, that is npn 4p4. But the 4 special flowers can be arranged in 4p4, that is equal to factorial 4 ways or not. It means the total number of garlands will be product of these two. Therefore, total number of such garlands will be equal to half into factorial 4 into factorial 4. And we know factorial 4 is 24. So it is half into 24 into 24. This cancels this 12 times. And this comes as 288. It means 288 different garlands can be formed from the 8 flowers, out of which 4 special flowers are always together. So now with these examples, circular permutations must have been more clear to you. In the next video, we are going to learn about the combinations. What is the difference between the permutations and combination, and what is the meaning of combinations and how to apply it. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.